Hey everybody and welcome. My name is Becky Weiss. I am an AWS engineer, virtual private cloud VPC. This is what I work on. And it is an honor and privilege to be here in my hometown of Chicago to talk to you about networking in EC2. Because that is what a VPC essentially is. It is your private network, a network that belongs to and is controlled by you in AWS. Now, as with anything in AWS, our customers represent a very wide spectrum of backgrounds. Some of our customers approach VPC from a deep background in traditional networking. Many of you might be from a background like this. You're a network engineer possibly, you've done networking in traditional data centers. And for those of you from this kind of background, you know how hard this is. It takes a great deal of expertise and a great deal of work. First of all, you need to know about networking concepts like routers, firewalls. You need to know about basic network services like DNS. And so you need to know how to configure these things and set them up and get them doing what you want. After you do that, there's ongoing maintenance and monitoring of these things to make sure that they're always working because your customers expect your network to always be working. And then even after you've done all of that, at the end of the day, you may or may not have quite the visibility you want into this network. Is it actually doing what you intend? Is it letting in the traffic you intend? Is it keeping out the traffic you intend? So for those of you from this background, you'll find, as we talk about the features of VPC, you're going to be able to draw many parallels between things you were used to being able to do in a traditional network and things that you can do in a VPC. But you'll find that a common thread is that in VPC, it's always easier, it's always lower maintenance, and it's always very easy to see what's going on and what you just did. Now then at the other end of the spectrum are customers who you're in AWS because you want to focus on your application. You want to focus on your business. The network is, of course, something that you need because you need connectivity. And in fact, you want to be in complete control of network security. This is important to you. But you don't want to get involved in a lot of fiddly details of networking. You want a secure network that's within your control, but mostly not thinking about it all the time. Now, for those of you, if you're approaching VPC from that angle, I anticipate that from the first half of this talk, you'll come away with pretty much everything you need to know to be productive and completely secure in AWS. Now, this is an introductory talk to VPC. If you are already an expert in VPC and you know about all of its features, you've probably come to the wrong place. This is going to be a grand tour of what VPC has to offer and kind of give you ideas for where to explore further. So let's begin. In EC2, Elastic Compute Cloud, the core unit of EC2 is that EC2 instance. It's a virtual machine in the cloud. Now, this is a virtual machine in the cloud. You're probably running a bunch of them, and in fact, the E is for elastic, so you're probably scaling these up, scaling these down, using what you need, not using what you don't need, and paying for what you use. Now, of course, these are virtual machines, so the only way to do anything interesting with them is with a network. So they run in a network. They run in AWS data centers in 12 regions around the world. But what the VPC is your network. The network that your EC2 instances run in each region is your network. The P is for private. It's a VPC. Now, what are some things you do with networks? Well, networks, you have IP addresses in your network, so your VPC is going to give you some of those, or you can choose your own addressing scheme. We're also going to talk about how you divide up this network to be able to achieve high availability for your applications in AWS. You may wish to have all or part or some of your network routable to and from the internet, so we're going to talk about how you do that. And that's what you're going to get out of this. You're going to learn enough here to be productive with VPC, because many of the concepts are very simple regardless of your networking background. For the first half, we're going to be getting familiar with very basic VPC concepts, the things that you need to know to set up the most basic of VPCs, which is going to be an internet-connected VPC. And I'm going to walk you through step by step what goes into this VPC so that you can actually see what this thing is made of and what all of these knobs are doing for you. And then in the second half of the talk, it's going to be the sort of and more part. More kinds of connectivity, more kinds of things you can do in your network and take control of it. So the most basic VPC out there is an internet-connected VPC. And as a matter of fact, you probably already have a VPC like this in your account. If your account was created anytime after 2013, you have something in you have a VPC in your account called a default VPC, and as the name suggests, we created this for you by default. The VPC we're about to walk through and set up step by step looks exactly like a default VPC. Now you can use your default VPC, but nevertheless it makes sense to understand the things that make up that VPC. So we're gonna go through this in 4 steps. We're gonna talk about picking addresses, we're gonna talk about high availability, then we'll talk about getting packets to and from the internet, routing, the core concept of a VPC. And then finally we're gonna talk about security, and I'm gonna show you getting security right in a VPC is not that hard. And I'm going to take you through examples. I'm going to be showing you screenshots of our console. I'm going to show you how you do this with UI. But for everything that I show you, you can do the exact equivalent things. These are all automatable. We have a CLI command line interface. We have SDKs in various programming languages. But screenshots make better slideware. So everything we do here is all automatable. OK, so first, we have a network. So a network needs IP addresses. And since this is a VPC, since I control it, I get to pick exactly what these addresses are going to be. So a quick piece of background for those of you who are not already familiar with this notation. This is SiteClassless interdomain routing notation. It looks like this, if you're not familiar with it, this is how you read it. It looks like an IPv4 address here. An IP address followed by a slash followed by a number. What that means is that if I take this IPv4 address with a 32-bit number and write it out in binary, /16 means I hold the high 16 bits fixed and the low 16 bits can vary. So in English, what that notation means, it's all the IP addresses that look like 172.31.something.something. So that's what this notation means, and we're going to be using it throughout this talk, and everywhere in VPC uses this notation. All right, so here's an address range I can pick for my VPC, 172.31.0.0/16. Now you might be wondering why I picked that particular address range. Here are some tips when you're picking an address range, because this is actually an important decision. Almost everything else that we're going to talk about with a VPC, the V is for virtual, which means that you can turn it on, try it, turn it off, change your mind later. The one thing that is fixed for the lifetime of the VPC is the address range, so it does behoove you to pick a good one. OK, so why did I pick this one? First of all, what I have here is an RFC 1918 range. RFC 1918, it's an RFC that defines address ranges conventionally used for private networks. And what we've got here is a private network. I recommend that you use an RFC 1918 range unless you have a real good reason not to, for the simple reason that whenever anybody on your team using instances in your VPC sees their IP addresses, they'll look like IP addresses from a private network. They'll make sense. Now the /16 means I get 65,000 addresses available in the VPC. And that might sound like a lot. And on behalf of AWS, I hope you use all of them. But you may not. And I recommend choosing a /16 for your VPC, again, unless you have a good reason not to. It's a nice big VPC. It doesn't cost anything to make a big VPC. And what you've done here is you've left yourself plenty of space to grow. Maybe today you're running 5 instances. Maybe tomorrow you're running a lot more than that when your business grows. And one other thing to consider when you're picking an address range for your VPC. In the latter half of this talk, we're going to talk about a bunch of other connectivity scenarios, things you can connect your VPC to. And in order to have the routing make sense, you want to make sure that those address ranges don't overlap. So if you know that you have your own corporate data center with an address range, or you might be having multiple VPCs that you want to connect up together, anything like that, make them non-overlapping so that you'll have an easy time connecting them later. Great, we've got addresses. Next, we're going to talk about subnets. And subnets in a VPC, subnetworks, they are subranges of the address space that you just picked for your VPC. And they are how you use your VPC to deploy high availability applications in AWS. And here's what I mean by that. So we have 12 regions worldwide. Your VPC, a VPC that you create, exists in one of these regions. For this example, I'm going to use our Dublin region, EU West 1. So this VPC, it lives in EU West 1. Now, EU West 1 and all of our other regions are divided into multiple availability zones. In Dublin has 3, EU West 1A, 1B, and 1C. And what these availability zones, you can almost think of these in traditional terms in terms of data centers. The concepts don't map quite one-to-one, but they have redundant networking, redundant power. They're specifically designed to have separate failure characteristics. There's geographic distance there. And you can see how this is a useful concept if you care about high availability. Because if I'm trying to deploy a highly available application, I'm going to want it deployed across multiple availability zones so that I can take advantage of all of that redundancy. Now, like I said, you want your VPC to span all of these availability zones, and subnets are how you do that. A subnet lives inside an availability zone. You can have as many subnets as you want within an availability zone, but a subnet doesn't span availability zones. And a subnet is a subnetwork into which you will ultimately be launching your EC2 instances. And you choose subranges of your VPC for that. So let me choose 172.31.0. something for the subnet in this AZ. Availability zone 172.31.1. something. You get the idea. Now, since we're creating an internet-connected VPC, one thing we probably want here, and you don't always want this, but for this simple default VPC-looking VPC, we're gonna set a bit on the subnets that has you opt into publicly routable IP addresses given to each instance that you launch there. This is just what we choose here. If you're looking for internet connectivity to each and every instance, this is what you want. You can override this on an instance-by-instance basis as you launch instances. And you can change this setting after the fact. But let's turn this on. So when we launch our instances, they're routable from the internet. And as you can see here, all instances will get an automatically assigned public IP. OK, now you saw that I did choose an address range for my subnets. And there's a few words on kind of what went into that choice. That was a deliberate choice. And these are guidelines, again, unless you have a reason to do something else. I made a nice big VPC. My subnets were a bit smaller. They were /24, which means I get 251 addresses available to me in each of these subnets. Now, those of you who are really good at math, you know that /24 should give me 256 addresses. The reason why you get 251 is we reserve the bottom 4 and the one high address in the range. So you get 251, which is still a lot, depending on your point of view. I put one subnet in each availability zone, and what I've done, since my subnets are a lot smaller than my VPC, I've got lots of space in my VPC around the subnet to be able to create new subnets in the future if I need more space out of my VPC. So I've left myself a lot of flexibility and headroom for the future. Great, we've got addresses. Now let's talk about the internet. This is where we're going to talk about the concept of the route table in the VPC. Now routing may sound like a complicated networking concept, and it can be. But in VPC, it's not. You'll see that it is actually fairly straightforward to see what's going on here. Your VPC has associated with it what we call a default route table. A default route table is a list of rules, and we'll look at them on the next slide, that basically dictate where if you're trying to send a packet to these addresses, they go here. If you're trying to send a packet to those addresses, they go there. And you can override this on a subnet by subnet basis. We'll talk later about times when that might make sense. So let's take a look at this default route table that I haven't touched yet. This is just what came out of the box with my VPC. Let's look at its rules. It came with one rule. One rule saying 172.31/16. So that CIDR range, you remember that was the address range of my VPC. If I'm sending a packet there, it's supposed to get routed locally. Whatever happens in my VPC stays in my VPC. Now you'll notice I don't have any other rules here. And the way routing works in a VPC is that if I'm sending a packet to an address that doesn't match any of my route rules, the packet gets dropped. It has nowhere to go. So right now, if I were to try to send a packet to the internet outside my VPC, it would have nowhere to go. So this is a party in my VPC and nobody's invited. And this is not what I want. I want to be able to send packets to the internet. So enter the internet gateway. An internet gateway is exactly what it sounds like. It's a gateway to the internet. It's a place you can send packets if you would like them to get to the internet. So I create one of these, I attach it to the VPC, and then I go back to my route table, and you'll see I created a new route here. 0/0, that's a catch-all rule. That'll match all packets, get sent to the IGW, to the internet gateway. And the way routing rules work in a VPC is the most specific rule that matches your packet is the one that dictates where the packet goes. So it's still true that if I'm sending a packet within my VPC, it's that local rule that will take effect, which is exactly what I want. Great, now my packets are getting to the internet, but I want security too. I want to get the traffic that I'm supposed to get at my EC2 instances in my VPC, but I don't want to get the traffic, I don't want to get anything else. I don't want to get any traffic that I didn't specifically want at my instances. And for this, we give you two tools in a VPC. They're slightly different from one another. One is called network ACKS. The other is called security groups. Security groups are far and away the most commonly used of these, and you'll see why. They're very flexible and can be made to follow the shape of your application. Network ACKS are a bit of a blunter tool, and honestly, you may or may not end up using them. Network ACKS, if you're coming from a traditional networking world and you're accustomed to having stateless firewalls, stateless firewalls means it doesn't care about the connection state of a packet. You have an outbound set of rules and an inbound set of rules, and those rules are just applied. It's a kind of blunt tool for traffic. You'll see that like the route table, they're applied on a subnet by subnet basis, but I have a main one for my VPC. You'll see that there's these rules here. They're applied in order according to CIDR rules. They should remind you a little bit of IP tables rules if you're familiar with those. And again, no connection tracking, totally stateless. You've got one of these for ingress, packets coming in. You got one of these for egress, packets going out. And this verdict is just applied regardless of connection state. This is the network ACKL that I got out of the box. And you'll see that if you interpret those rules, you see that I'm allowing everything. And that's because I'm going to use security groups. And you can use both in conjunction. But security groups are something that everybody deploying applications on AWS who wants to be secure is going to take advantage of. Security groups are best explained with an example. So I'm going to give you a really simple example of an application that I've deployed here on AWS. It consists of some web servers, and these are web servers that I want open to the world, taking everybody in the world's HTTP traffic. And in the course of handling my customers' requests, they're going to turn around and make calls to a fleet of backend servers. Okay, now let me think about network security here. What do I want to restrict this thing down to? Well, for one thing, there are two different security groupings here, right? There's the group of web servers, there's the group of backends, and each of them, I have different kinds of traffic that I'm looking to allow. So that's what a security group is. A security group is a group of instances that all have in common what kinds of network traffic they're going to allow. So if I think about the web server security group, I'm trying to allow web traffic from everywhere. But I probably only want web traffic. I don't want the world trying to SSH to these instances, for example. So I want only that specific port, but open to all addresses. For the backends, I actually only want anything that has a membership in the web servers to be able to talk to it. Certainly nobody from the internet. And I can lock it down even further. If you're not a web server, I don't want you sending traffic. And it probably has a specific port that the backend service is running on. I'm using 2345 in this example. So this is what security groups let you express exactly what I just said. They're a stateful firewall, which is actually typically what you want. Stateful means that they do connection tracking, which means you need to allow the packet that initiates the connection, but once the connection is established, the return traffic for this established connection is allowed. And like I said, that's usually what you want. So we're looking at the ingress, inbound security group rules for the web servers group. And you'll see here, I've got one rule here, HTTP, so that's TCP port 80. I'm allowing everything. That's pretty simple. And if somebody initiates a connection to me and it doesn't match this rule, it's on some other port, my instance is not going to receive that packet. So that's what I want. Now let's move on to the back ends and look at their security group. And you'll see you can have multiple rules here, but to keep things simple, I have one rule on each. Now this rule, if you look at this rule, you'll see that, okay, port 2345, I'm not talking about a specific range, IP address range or list of IP address ranges. I'm actually referring to another security group. That's the identifier of the My Web Servers security group. And you can see how this, you can probably instantly see how this is easier to manage than what you might have been doing with firewalls before, where either you would have to open it up to some range and kind of hope for the best, even though you knew that you knew that there might be some holes in that range, or maybe you tried to keep up with a laundry list of specific hosts. This makes things easy. In EC2, the web servers, I'm probably going to be scaling that thing up and scaling it down and terminating and launching instances into that group all the time. I might even be having an auto-scaling group do this for me. That's okay. All these instances, they have membership in the correct security groups, and I don't need to stay on top of what the list of instances is at any given point in time that needs to get into the backends. A couple more notes about security groups before we move on. I showed you ingress security groups, but we also have egress security groups in VPC. Generally, ingress groups are used more often than egress groups, but egress groups are how egress security group rules are what you specify if you want to limit what kinds of connections can be initiated from your instances. So that gives you a level of control in the other direction. As a best practice, you should do what I did. Whenever you can refer to other security groups, you should, just because that's much lower maintenance and easier to stay on top of and see what's happening. And finally, one pattern that I observe with customers who are following security best practices as they deploy their applications. EC2 gives you the ability to launch an EC2 instance into something called an IAM role. IAM stands for Identity and Access Management. An IAM role that you launch an EC2 instance grants it permissions, specific permissions that you specify, what operations it can do in AWS on behalf of your account, without having to smear credentials across all over the place, which would be a security worst practice. So IAM roles give you a nice clean way to authorize your instances to do specific things. So your IAM role is what your instance can do. Your security group is who your instance can talk to. So you can see how there might be a natural one-to-one relationship between these two concepts. And this is something that I often see, this one-to-one relationship between what you can do, your IAM role, and who you can talk to, your security groups. You know what? At this point, if you're looking to create an internet-connected VPC, you probably know almost everything there is that you need to know to be productive here and to be completely secure. These security groups, if you architect them after the shape of your application, you're secure. But there are some more connectivity options that you might be interested in, just depending on the needs of your deployment and your workloads. We're going to talk about 3 of them here. We're going to talk about, remember I mentioned that routing is done on a subnet by subnet basis. I'll show you a little bit more about that, and specifically about how maybe you don't want internet access on your entire VPC and what you can do about that. Then we'll talk about a feature called VPC Peering that allows you to connect multiple VPCs, sometimes even across multiple accounts. And then we'll talk about your on-premises network if you have one, because many of you are in the process of migrating to the cloud, and for a long time you're going to have a network on-premises and a network in VPC, and you want these 2 networks to function as extensions of one another to be able to allow for a seamless migration and great secure connectivity between these networks. Okay, so first let's talk a little bit about routing on a subnet by subnet basis. That VPC we created before in your default VPC, it's got internet connectivity from all of its subnets. And that's good, and remember we had this application with web servers and backends. They were in different security groups, which you should definitely do regardless of what you do with subnets and routing. But you might have compliance, various regulatory compliance needs that require you to, let's say these backends were handling sensitive data, require you to prove that they are not even routable from the internet. They don't have publicly routable IP addresses, and there is no route between them and the internet. Or you may just be looking to take kind of a belt suspenders and mitten clips approach here and make sure that they really are disconnected from the internet. So what you can do in addition to security groups is you can put them in different subnets. And since subnets are the unit at which you can do routing, I can have the web servers have a route to the internet, but the backends would have just that local route. So the backends are only reachable from the VPC. There's no route. But the web servers are reachable from the internet. I'm going to redraw this picture with these two subnets side by side. Over on the left-hand side, we're going to have what our documentation calls a private subnet. And very precisely, a private subnet is a subnet that has no route to the internet. And on the right-hand side, we're going to have a subnet with a route to the internet, what our documentation calls a public subnet. OK, now often when you have a setup like this, it's not exactly true that you want the private subnet completely cut off from the internet. You want the instances in there, you do not want them to have public IP addresses, and you don't want them to be reachable from the internet. But you do want them to be able to initiate outbound connections. For example, they may need to reach out to a Yum repo to update their software. So you want them to be able to initiate these connections and get replies back, but you don't want the outside to be able to initiate connections to them. And that is why you would use our NAT gateway. NAT gateway is a new feature that we announced just this last December. And what it does is it takes care of network address translation for you in a completely managed way. So a very low touch, low maintenance way to do NAT, network address translation. Because the traditional approach to being able to do this sort of private subnet thing is to have a single public IP address behind which they can all send traffic to the internet. The packets that they send are natted so that out on the internet it looks like all of the traffic is coming from this single IP address. And of course the NAT is also doing some connection state tracking so that the replies get back to the respective instances that they should. So that's what a NAT gateway is. That's a NAT gateway. The way you set up a NAT gateway is you associate a single public IP address for it. The NAT gateway itself, of course, must live in your public subnet because it has a public IP address and it's going to talk to the internet. But from your private subnet, you're going to create a route. You're going to say 0/0 traffic. It's not going to go to an internet gateway anymore because that's not what I want here. It's going to go to a NAT gateway. And then it's going to work exactly like a NAT. The packet's going to go to the NAT gateway. The NAT gateway will make it look like the traffic's coming from 54.161.0.39 out to the internet, back to the NAT gateway, do the NAT the other way, get it back to your instance. And like the internet gateway, this thing is it's not something you manage, it's something we manage. It's not a single point of failure. It's a highly available gateway that's managed by us that does all of this natting and connection tracking just for you out of the box. So that makes it very easy to have this public and private subnet and still have the connectivity you want without anything that you have to manage on an ongoing basis. Let's talk about other VPCs. So there are many setups that call for you to need private connectivity between multiple VPCs. Here's a very common one. Let's say you work at a large organization that, for various reasons may wish to have multiple AWS accounts, maybe for separation of billing or for other kinds of reasons. And you have all of these teams around your organization. Maybe you've given them each an account. So each of them is going to have its own VPC or VPCs. But you have some organization-wide shared services. There's a list of them here. And some of them might, in fact, be cost prohibitive to replicate in all of your team's satellite VPCs over there. Now, one approach is you could have a shared services VPC. You could put these internal services out on the internet, and that would work. but often you don't want to. Often you don't want to have to, for example, attach an internet gateway, make this stuff publicly routable just in order to accomplish that. So this is where VPC peering comes in. VPC peering is two VPCs in the same region with non-overlapping IP address ranges between which you can establish private connectivity within the region. And as a matter of fact, we just announced a pretty important improvement to VPC peering just this past February. You remember security groups and how you can allow one security group into another and how that's a nice flexible way to define security after your applications? Well, you can now do this across a peering too. So blue security group can specify a security group over an orange VPC and allow just that traffic in. And you can see if blue is vending some shared services from there, you can see how this might be very useful. All right, so a peering can involve multiple accounts. You can peer across accounts, you can peer two networks within an account, and because of that, a peering doesn't happen until both sides have completed a two-way handshake. So the handshake kind of looks like this. Orange VPC initiates a peering request to blue VPC. Orange VPC knows blue VPC's account number and VPC ID in order to do this. It looks like this. You can see here how you say my account or another account. Blue VPC's job is then to review that request and accept or reject it. That's going to look like this. Blue VPC is going to see something over here that says pending acceptance. It's going to accept it, and now, and only now, is there a peering. There's a peering here, but everything interesting that happens in a VPC happens because of a route. So now we're going to create a route to the peering connection. We're going to create routes, and they're going to look like this. It's going to look like this one right here. PCX stands for peering connection. And what this looks like is in orange VPC, if I'm sending a packet to 10.55. something, that means it's supposed to go to the blue VPC. That means it's supposed to go to the peering connection. Now you'll see my route table is getting a little bit longer here. But even though it's getting longer, it's very readable. You can look at this route table and see exactly what your intentions are with getting packets around and out of your VPC. You can see where everything is intended to go. Now you might be noticing that there's another rule at the bottom of this route table that you don't know what that does yet. What that does, that's a VGW, that's a virtual gateway. That gets you back to your on-premises network. So we're going to talk about VPN, Virtual Private Network, and Direct Connect. These are a pair of technologies that allow you to make your VPC an extension of your on-premises network by creating a private and secure connection between them. As a little point of history, this feature, this ability to connect your on-premises data center to your VPC, was in fact the genesis of the VPC product. EC2 existed before VPC. There was an EC2 before there was a VPC. Before there was a VPC, you could launch an EC2 instance, and it would come up with it. It would have a private IP address that would be in the 10 dot range. Amazon would pick it for you. It would be in a flat network, so you'd get your 10 dot range. And you had a choice between internet connectivity or internet connectivity, so you got internet connectivity and a public IP address also chosen by Amazon. And you didn't own the network, right? This wasn't a network that you owned. You got virtual machines in the cloud. This thing is called EC2 Classic. It still exists for older accounts. If you're using EC2 Classic, it definitely makes sense to take a look at VPC features, just because it offers you more control of your network. But that's how the world was before VPC. Now, we had customers, larger customers, looking at migrating their workloads to the cloud, and these customers, they had their own networks that they were going to need to be able to securely connect to these hosts, these virtual machines they were going to be running in the cloud. Now, many of these customers themselves had addresses in the 10 dot range. So how was that going to work? And we realized what we needed to do was give customers a network that they could control, that they could, for example, define the addresses for, and that they could connect up. So this is actually where VPC was born, even though now it is only one of many things that it does. So that's what this does. You got your data center on your left, you got your VPC on your right, and you can use VPN to connect them. You can use Direct Connect. I'm going to very quickly touch on some concepts you need to know to set up a VPN, and then talk to you about kind of the difference between VPN and Direct Connect and sort of what you need to know. This is a deeper topic. As you might imagine, it involves more networking because there's networking on the left-hand side of the picture that you manage. But here's what you need to know about VPN. VPN involves a networking device in your data center that you manage. It's called a customer gateway. You're the customer, and it's your gateway. This is your side of the VPN connection. There's a long list of network devices from various vendors that we support and specific documentation for each of these, how you get it set up. But this is your end of the encrypted IPsec connection for your VPC. Your customer gateway, because the VPN connection is going to go over the internet, your customer gateway is going to have a static public IP address associated with it that we can reach. On our side is a virtual gateway. Now, the word gateway should be setting off bells in your head by now. So our side's a virtual gateway, your side's a customer gateway. If you follow our instructions, you end up setting up 2 redundant IPsec tunnels between your customer gateway and our virtual gateway. 2 IPsec tunnels, that's for redundancy's sake, and in fact, they terminate in different availability zones over on our end. And that's us taking advantage of our own high availability concepts to give you a highly available VPN connection. So there you have it. You've got your IPsec connection between your data center and your VPC, and what route propagation is done via BGP if your device supports that. Otherwise, you can do static route propagation. And now you've made it so that if you're in the VPC and you're sending traffic to your data center, let's say it's a 192.168 address, it gets to your data center. And if you're in the data center and you send traffic to 172.31. something, it gets where it's supposed to go. And again, this is done with a route. There's your route, goes to a virtual gateway, looks like all the other routes. 192.168 going to my data center, it's going to go to the virtual gateway, and it gets routed correctly. Now, we talked about VPN. Direct Connect achieves the same goal, a private connection between your network and your VPC. VPN goes over the internet. It's a pair of IPsec tunnels. Direct Connect is what it sounds like. It's a direct connection in one of our many co-location centers around the world between your equipment and ours. So there's actually there's a physical cable between your equipment and ours. You would pick Direct Connect over VPN if you have higher data transfer needs. Direct Connect offers higher port speeds, 1 gig and 10 gig. It also offers a lower per gigabit data transfer rate. So higher data transfer needs, you're probably looking at Direct Connect. We see customers use both to set up a Direct Connect with redundant VPN behind it for a really highly available connection. All right, so that's enough about connectivity. Let's talk about some other services of a network, something you may not even always think about. Let's talk about DNS, because in a network, whoever's running in your network is going to need to be able to resolve DNS names, domain names. Now, VPC does DNS for you, and you'll see that there are 2 DNS options here. The vast majority of customers choose yes for both of these. The first question is, do you want AWS to do DNS for you? And you probably don't want to be. You're probably in this business because you don't want to be operating your own DNS and things like that, so you're probably going to say yes. The vast majority of our customers do, but you can. VPC is really flexible. You can run your own DNS, and our documentation explains how to do that. The second one is, do I want to get EC2 DNS names on my EC2 instances? Let me show you what you get if you say yes for this. Whenever I launch an instance, I get 2 DNS names for the price of 0. The first one here looks like it has my private IP address embedded in it, and it does. And when I resolve that in my VPC, I get exactly what you would expect, the private IP address that looks like it's part of that string. The second DNS name is a little more interesting. This one looks like I have a public IP address on this instance. This one looks like it has the public IP address embedded in it. Now, this DNS name has some very useful characteristics in that it resolves to the right answer from wherever I'm asking. So if I'm outside the VPC, here I'm outside this VPC on some Windows machine somewhere, so I do an NS lookup of this DNS name, and I get the public IP address back. And that's the right answer. If I'm outside the VPC and I'm trying to talk to this instance, EC2 instance that has a public IP address, I should be using its public IP address. That's how it's publicly routable from the internet. Now, if I then go inside my VPC and do the same query, you'll see I get a different answer. I get the private IP address of my instance. So the DNS in my VPC was smart enough to realize that I should be using a private IP address to talk to this instance. You always want to use IP addresses inside your network to communicate within your network, and that makes it so that your security groups work and all of that. So I've got this nice DNS name, and by the way, the DNS names, I'm not showing this here, but the DNS names that other services like Relational Database Service, RDS, Elastic Load Balancer, ELB, all these services give you DNS names that if you resolve them, you'll see that they're canonical names, CNAME entries, for EC2 host names, the EC2 instance that, for example, your RDS database is actually running on. And you'll see that, again, they resolve to the right address, the right way to reach your RDS database from wherever you're asking. But there's even more that you can do with DNS in your VPC. This is an especially neat feature of VPC. It's called Route 53 Private Hosted Zones. What it lets you do, there's some words on this slide about what it does. It lets you be DNS God in your VPC. It lets you take over certain domains for VPC, for inside your VPC, and specify exactly how DNS is supposed to work. And you can do all of this without having deep knowledge of DNS, without operating any DNS machinery. And yet, you can completely control your DNS using this capability to give you kind of a split horizon kind of DNS if that's what you want. I'm over here in the Route 53 control plane because that's where you go to do all things DNS. You'll see that I'm going to set up a private hosted zone on demohostedzone.org. You know, you don't even need to own this domain. I don't own demohostedzone.org. I don't think anybody does. Route 53 lets you create public or private hosted zones. Public hosted zones means they are DNS zones out on the internet, you know, where you say how everybody's going to resolve this domain, then you need to own it. But for a VPC, you don't. So I've got my private hosted zone. I've specified one or more VPCs that I want it to take effect in. I go into my hosted zone and I start creating some records. Let me create an A record that'll resolve to an IPv4 address to example.demohostedzone.org, and this is what I say it should resolve to. Great. I'm going to go to an instance in my VPC. I'm going to try resolving that, and look, it resolved exactly to what I said it should. So that's DNS, a service that's usually that can be pretty hard to run, can be pretty hard to operate, that's just done for you, and you have tremendous control over it. And there's a couple more little things that I want to touch on here. One thing that we released almost exactly a year ago was something called VPC Flow Logs. VPC, if you turn on VPC Flow Logs, so VPC Flow Logs, they're great for a whole host of compliance and security needs. They're also really useful for debugging. What it does, if you turn on VPC Flow Logs, and you can turn it on for individual instances, for a whole subnet at a time, for a whole VPC at a time, what you get if you turn on VPC Flow Logs is you get a full aggregated dump of all of the packet metadata. So I'm talking source IP address, destination IP address, source port, destination port, protocol. You get all of that aggregated metadata to be able to, in dumps, in CloudWatch logs, where you can easily just go and pick it up and run scripts over it and analyze it. So you can see for each of your EC2 instances exactly who was trying to talk to it, who it was trying to talk to, and how much. You can even see, if you opt to, you can see the packets that actually reached your instances because they were allowed in, and you can also see the packets that were rejected because you wrote a security group, so you can see who's trying to get past your security group and getting blocked. So you have an incredible amount of visibility into what's actually flowing around your VPC. Now, in a traditional network, there are ways to do this. There's a lot to set up in order to be able to do this. You need something collecting all that metadata on each of your hosts. You need somewhere to send it. You need something to aggregate it. You need a place to put it, to pick it up. This is literally turning something on and then coming back a couple minutes later to pick it up. I've used this for debugging. That's one thing it's very useful for. But you can see all kinds of analytics. One very interesting application here is you can look at your flow logs, compare them with your security groups, see if your security groups are clamped down as tightly as they need to be, for example. Here's another thing we released last year that also increases the level of control that you have in your VPC. VPC endpoints for S3. So S3, simple storage service. Many of you are running your applications on EC2. You're running EC2 instances, and your data lives in S3. That's a very, very common setup. And your data is, part of your application. And until you had a VPC endpoint, you'd need S3 is at a public IP address, and you would need internet access to be able to send requests to S3. What the VPC endpoint allows you to do, another way to think about it is it's almost an S3 gateway in your VPC. In fact, it goes in your route table. I'm not showing you that here, but it goes in your route table like all of these other routes. And they make it so that you can get to S3 without an internet gateway. And you didn't have to change any of your code. The same DNS name for S3 resolves to the same public IP addresses, but that traffic doesn't get routed through the internet. It goes directly to S3. But it gives you even more control than that. It allows you to use IAM policy, Identity and Access Management Policy, to really lock down this channel between your VPC and S3. And what I mean by that is this. Your VPC endpoint, it's an object in your VPC, and you can put IAM policy on it. You can author IAM policy that says exactly what callers in this VPC are allowed to do in S3 and, and on what resources in S3. It looks a lot like any IAM policy that you might author, but it applies specifically to callers from this VPC. And you can also lock down the other end. You can also author policy on your S3 bucket that references your VPC endpoint. In other words, I can create a policy on my S3 bucket that says, unless you're this VPC calling from this VPC endpoint, you can't talk to me. So you can see what I've just done. I've just kind of created sort of an if and only if between my VPC and S3. I've really clamped down this channel. So now I control not only the VPC and the network, but also its data in S3. So being able to lock down S3 access like this, visibility tools like VPC Flow Logs, network management tools like all the power you have over DNS, all these connectivity scenarios that we talked about, these are all your tools for building a low maintenance, easy, flexible, but as secure as you need it to be, network in the cloud. Thank you very much.